Greetings and welcome. We've been talking about translations of sine and cosine functions, and we're on page like 383-ish, around there. Technically, this problem's on the next page. Here's question 19. It says state the vertical shift and the equation of the midline for each function, then graph each function. All right. So I might actually rewrite this as y equals cosine of 2 theta plus 7. All right, and some values to point out is that, let's see, a is equal to 1, so the amplitude is going to equal to 1. The value of k is 2. We'll use that to calculate our period in a moment. Let's see, what did I call this? Was this h? I'm trying to remember. Yeah, it was c for the phase shift. Yeah, craziest letter selection for this. H, well, I guess I'll say C is equal to 0, H is equal to 7. So our V shift is going to be up 7 units, right? And the midline is going to be Y equals 7, right? Let's see, so other things we can gather is that the amplitude is equal to 1. The period is equal to 2 pi over 2, which is just plain old pi, right? So all sorts of stuff that I could gather from that. Let's see, I didn't realize apparently that I was originally going to have to graph this, but I can fit it in here. Let's do this. So let's see, it's been shifted up 7. Oh, maybe I should draw this a little bit further down. Question, actually, before I even go any further, let me ask you, what is the max and min? The maximum, well, yeah, the amplitude's 1, so it's going as high as 1 above the midline and as low as 1 below the midline. So yeah, 7 plus 1 is 8, 7 minus 1 is 6. Alright, so technically, I got an idea. I might even throw one of these zigzags in my sketch. I don't know if you've seen those before. Classic. So I'll actually have 6, 7, and 8 be here, just so I kind of fit it nicely, especially considering the room I gave myself. Let's see, so the period is pi units. Half of pi is pi over 2. Half of pi over 2 is pi over 4. And 3 pi's over 4 is 3 pi's over 4. All right? And there was no horizontal shift, no phase shift for me to worry about on this, so I don't have to worry at all about that. I guess I could start by going with the midline here. And let's see, so this is a cosine function. Aha! So cosine at 0 starts at its maximum value, then it goes down to its midline, then it goes down to its minimum, then up to its midline, and up to its maximum. Right, and I'm going to try to draw this somewhat curvy here. Oh, yeah, that was kind of sad looking. Right, something like that-ish. And it would, that was a sad little part right there. I'll keep that, whatever. So this is what the function would look like. Something to that effect, right? And all that information I was able to gather from there. Not too difficult. So vertical shifts weren't that bad. I just want to point out once again that the maximum was the value of the amplitude plus the midline, and the minimum would be the midline minus the amplitude, or something to that effect. Would be fine for calculating that. Let's see, question 23. It says state the amplitude, period, phase shift, and vertical shift for each function, then graph the function. So here we go. Now notice they're actually putting kind of the V shift at the front end. I'm going to rewrite this a little bit. So let's see, I could actually even write this as 1/3 theta minus pi over 2, and then minus 2 on the outside. You don't have to write that 1/3 quite that way, but you could. So let's see, this is, oh sorry, pi over 12, yeah. There we go, pi over 12, aha. So let's label what we know. I know A is 1. I know K is 1/3, right? And make sure that you'd be able to determine by looking at theta over 3 that your value of K is technically 1/3, right? Being multiplied by theta, or our x in some cases. The value of c is negative pi over 12, and the value of h is negative 2. So information we can gather from this: the amplitude is 1. All right, the period is going to equal 2 pi divided by a third, which is 6 pi. Aha! Dividing by a third is the same as multiplying by 3. Let's see, phase shift. I might need some. I'll do it here. I'll just call it PS for phase shift. Let's see. Was equal to what? Negative c over k. You guys recall? So I'm going to take this, divide by that. So negative pi over 12 divided by a third. Now dividing by a third, as I said a moment ago, is the same as multiplying by 3. Actually, and I said negative of that, so yeah, technically, sorry, that would be opposite. So this is going to be pi twelfths multiplied by 3 over 1. 12 and 3 cross cancel partially. I'm going to get pi over 4 as my phase shift. All right, so that was one of the new concepts for us. And then vertical shift. Is going to equal down 2. All right, and let's throw in some more information here. What's the midline? Y equals negative 2, right? Because it's shifted down 2. And we can also throw in the max and min here, which it technically, min. It technically didn't ask for them. Oh. No. What? Oh, sneeze? Nope. No. It went away. How sad. Anyways, the maximum value would be the value of the amplitude plus the midline, I suppose. So negative 2 plus 1 is negative 1. The minimum is going to be the midline minus the amplitude, right? So negative 3 right there. So let's giraffe this. Why not, shall we? So let's see. So it looks like it's primarily occurring beneath the x-axis. Completely occurring anyway, more specifically. So let's see, negative 1, negative 2, negative 3. And I'm going to go over as far as 6 pi. And what am I shifting by? Pi over 4. And in which direction am I shifting by pi over 4? To the right? So this was negative, so it's shifting to the right by pi over 4. So I'm going to have to make sure, if this is 6 pi, that I've given myself enough margin to shift it to the right by pi over 4 units once I'm all said and done. So let's see, half of 6 pi is 3 pi. Half of 3 pi would be 3 pi over 2. And 3 of those quarter marks would be 6 pi over, no, 9 pi over 2. I was about to say, it can't be 6 pi over 2. 9 pi over 2. Yeah, so I always go from the full period to the half, to the quarter, to the 3/4 is what I do. And so you multiply the quarter by 3, and that's how you could kind of get that tick mark there the easiest way. And we're going to end up having to throw some pi over 4 units in here in a second as well. I guess we could try to figure that out right now. Let's see, what is, well, I guess I could throw in some tick marks. This would be 3 pi over 4. Right, it'd be half of that. So this would have been 4 pi over 4, 5 pi over 4, 6 pi over 4. No. What did I do wrong? Wait a minute. 3 pi over 4. Wait a minute. Guys, what am I doing wrong here? Why am I not seeing my mistake? 3 pi over 2, yep, I agree with that. Half of 3 pi over 2 is 3 pi over 4, agreed. So double that would have been 6 pi, okay, yeah. Or plus a 3 pi over 4, that's what I have to add. I was adding pi over 4, that's why I was thrown off. So 6 pi over 4, then this would be 9 pi over 4, yikes. and then 12 pi over 4. 12 divided by 4 is 3. And then 12 plus 3 is 15 pi over 4, right? Yeah, this still isn't going to be enough for us. And then 18 pi over 4 is 9 halves, right? And 21 pi over 4. Let's see if I can write 21 in pi and not incorporate the 1 into the pi. And then this would have been 24 pi over 4, and then 27 pi over 4. So there still is 3 pi over 4 units here, so my shift is actually going to be a third of those, but we'll leave it at that for now. So let's see, let's graph our midline was occurring at -2. And let's start plotting some of our, well, I'll plot the pre-phase shifted graph, how about? Now, let's see, we've got a sine function, so it's going to start at its midline, right? Then it would go up to its maximum, right? And remember, I'm kind of targeting these as the main ones here. Then it goes down to the midline, then down to its minimum, and then up to its maximum, right? Something like this. And I'm going to shift now all of these points to the right by pi over 4. Now, these tick marks are 3 pi's over 4, so technically a third of that would be what I'm shifting by, okay? So I'm shifting this over a third of that, over a third of my tick mark, over a third, right? And when I plot these, I'll have that, and that. So my graph would look something like this. And it would continue to repeat forever in both directions. All right, so something to that effect is what we would see. So yeah, this one was, I think, one of the first problems we've had where the phase shift didn't line nicely up with my quarter marks for the period. So that's why it ended up, landing at kind of weird locations there. But it still all works out for us. It's not that bad. Not bad. All right, one last question. Let's see. Keep cruising here. Where's my mouse? Here we are. There we are. All right, last question. Here, they've given us some facts and they want us to write the equation of, in this case, a cosine function. All right, that's key. With each amplitude, period, phase shift, and vertical shift. All right, so if the amplitude is 100, that means A is plus or minus 100, right? Could have been either of those because the absolute value of the A is equal to the amplitude. If the period is 45, well, 45 is equal to 2 pi over k. So if I want to solve that for k, some people cross multiply. After doing some work, you'd end up getting k is equal to, let's see, I could flip it, multiply by 2 pi over 45. Yep. So there's the value of k. The phase shift is 0, so that means the value of c is going to equal 0. And the vertical shift is negative 110, so that means the value of h is negative 110. All right? And now I can write my equation. So I'm going to have y equals plus or minus 100 times the cosine of 2 pi 45ths x. I'll use x instead of theta in this case. Minus 110. Not bad, not bad. So there's two possible answers to that. And there we go. Let's see, what question was that? 33. Yeah, we're good. We're good. So there we go, friends. Thanks for watching. Have a great day. Bye-bye.